Hello everyone, myself Sandal Gupta and I am a student of MC6M and today I am going to explain some topics of basic file attributes. So let's start with our video. The first topic of our basic file attributes is the -d option or listing directory attributes. We know that ls when used with directory names lists files in the directory rather than the directory itself. So to force ls to list attributes of directory, we need to use directory option, that is -d. Now in the given listings in the slides, directories are easily identified by first character of the first column, which is d. Here as you can see, in the first column the first character is d, so hence we can say that it is a directory. Similarly, if there is a hyphen in the first column as first character, then it's an ordinary files, and if there is b or c, then they are device files. Now if we want to see the attributes of a directory rather than the files in it, we use ls-ld with directory name. Like in this listing, we used ls-ld. Now moving to the second topic of our presentation, we will now understand file ownership in brief in this topic. Before we proceed to file permissions, it is necessary for us to understand file ownership. As you can see on the screen, it's written that every file and directory on our Unix system is assigned three types of owner. The first one is user. Now in simple terms, we can say user is the owner of the file, means the user created the file. Now when you create a file, your username shows up in the third column of the files listing. Now if we go back one slide, we can see that Kumar here is the owner of the file, or we can say Kumar is user. Now moving to the second one, group. A group can contain multiple users. All users of a group will have the same permissions to the file. Suppose you have a project where a number of people require access to a file. Instead of manually assigning permissions to each user, you could add all users to a group and assign group permissions to file such that only this group members and no one else can read or modify the files. Hope you understand what is group with this example. Now again, if we go back one slide to our last topic, so the fourth column of the file listings give your group name and your group is the group owner of the file. Moving on. Now the third type of owner is other. In simple terms, we can understand other as it's accessible by anyone. An other user neither creates the file nor he belongs to user group, but still it has access to the file. This is the third and last type of owner. Now moving on to our next part to understand what is UID and GID. So what is UID and GID? UID and GID are simply the parameters that has been assigned to the user when system administrator creates a user account. Unix-like operating systems identify a user by value called user identifier, that is UID, and identify group by group identifier, that is GID. Both are used to determine which system resources group or users can access. Moving to the next slide. The file /etc/password maintains the UID, both the number and name, and GID but only the number, while /etc/group contains the GID, both number and name. Now to know your own UID and GID without viewing /etc/password and /etc/group, we use the ID command. You can see in the slide that we have used the ID command. Here the UID is Kumar, and if this matches to the third column of field listing, then you are the owner of the file. Similarly, here GID is Metal, and if this matches with the fourth column of field listing, then you are the group owner. Now moving on to the last topic of our presentation, that is file permissions. We have understood file ownership in last slides, so it will be easy for us to understand file permissions. Every file and directory in Unix system has three permissions defined for the three owners we discussed in our previous slides. These three permissions are given as follows. First one is read. Now this permission gives you the authority to open and read a file. Read permissions on a directory also gives you the ability to list its content. In simple word, read permission will only allow to read the file. Now the second permission is write. The write permission gives you the authority to modify the contents of a file. In simple terms, the write permission on a directory gives permission to add, remove and rename files stored in the directory. Consider a scenario where you have write permissions on file but do not have write permissions on directory. Then we will be able to modify file contents, but we will not be able to rename, move or remove file from the directory. Now the third and last permission is execute. In Windows, an executable program usually has an extension .exe and which you can easily run, but in Unix you cannot run a program unless the execute permission is set. If the execute permission is not set, you might still be able to see or modify the program code, but not run it. Now below you can see a diagrammatical representation of owners assigned permission on every file and directory. Now moving on. Unix has a simple and well-defined system of assigning permissions to files. Let's issue the ls-l command once again to view the permissions of few files. Observe the first column that represents the file permissions. These permissions are also different for 3 files. Unix follows a 3-tiered file protection system that determines the file's access rights. To understand how this system works, let's break up the permission string of the file chap2 into 3 groups. The hyphen represents an ordinary file and is left out of the permission string. Another one is R, which indicates read permissions. Then W indicates the write permission and X represents the execute permission. Now in the next slide, we will discuss the 3 groups that are RWX, R-X, R-. The first group, RWX, has all 3 permissions that file is readable, writable and executable by the owner, which is Kumar. We have discussed that third column shows the owner. The second group is R-X group. This group has hyphen in the middle slot, which indicates that the write permission is absent in this group. So by the group owner of the file, and as we have discussed in the previous slides, we know fourth column shows the group owner, that is metal here. And the third and last group is R-. This group has write and execute bits absent because we can see the hyphen in the group at that place. So this set of permission is applicable to others, that is to the world. Now here we have covered all 3 main topics of basic file attributes. Now we will solve some questions of test your understanding. The first question is, how will you double space a file? So for double spacing a file, we will run pr-t-d foo. Here foo is being used to name entities such as variables, functions and commands. Second part of the question is, how will you produce a list of all files in the current directory without headers but in 3 columns? Now to produce list of files in current directory, we use ls command. So the answer to the question is lspr-t-3. -3 lists the files in 3 columns. Now moving to the second question. What happens when you use head with multiple file names? The head command is the name, as the name implies, print the top n number of data of the given input. So by default it prints the first 10 lines of the specified files. If more than one file name is provided, then the data from each file is preceded by its file name. So that's what the answer explains us, that head picks up 10 lines from each file but precedes each group with a header that shows the file name. Moving to the next question. How do you display the PS output without the header file? The PS command generally reports information on current running processes, outputting to the standard output. In simple words, it is used to find the process identifier numbers. So the answer to the question is PS tail plus 2. The fourth question in our slide is as follows. You need to run a program out that continuously writes to a file foo. How will you run the program and then monitor the growth of this file f from the same terminal? So the answer to the question is that we have to run out in the background with AND command and then use tail f foo. Last question of our presentation is, will this command work? The command is given cut -n -c1 -f2 f00. So no, this command won't work, as you can only use one options -c and -f. So here we complete our video. Hope you all understood some basic topics of file attributes. Please comment and tell how was the video. Thank you once again everyone for watching this video.